Welcome back to Space Mystery. Ever wondered how these glowing orbs light up our world? The precise crafting of the filament that produces light. Get ready to light up your knowledge. Let's dive in. How are incandescent light bulbs made? Bulbs are devices that convert electrical energy into light. They transform electricity into such intense heat that it shines. They are composed of a tungsten filament that heats up to over 1,300 degrees Celsius. But how are more than 50,000 bulbs made in an hour? In this video, when Edison invented a carbon filament that burned for 40 hours. A year later, he made a bulb that burned for over 1,200 hours. This finally made electric lighting feasible. The filament is very special. It's made with tungsten and can withstand high temperatures. It's the metal with the highest boiling point, reaching a temperature of 2,500 degrees Celsius, 3 times hotter than lava. The bulb is filled with a special gas that slows down the evaporation of the filament and is a poor conductor of heat. This gas helps to keep it cooler than it should be. If it had oxygen, the filament would disintegrate and even burn. Its base has 2 metal contacts that connect to a metal filament. The electrons from the electrical current collide with the atoms of the filament and make them vibrate. This energy heats the atoms to 2,200 degrees, a temperature at which they emit visible light. The bulb factory has 2 production lines. One prepares the glass bulb, and the other assembles the electrical components inside. The bulb production doesn't start with the metal filament, but with the bulb itself. The glass is made with a mixture of lime from limestone, potassium, a kind of natural bicarbonate, and sand. The factory consumes tons of this raw material every year. Lime stabilizes the glass when melted, and potassium reduces the required melting temperature. All ingredients are mixed and put into a massive furnace the size of an office building. But there's one surprising final ingredient left: recycled bulbs. These accelerate the process and reduce the energy needed to melt the ingredients. They need to reach a temperature of 1,600 degrees Celsius, hotter than lava. Once the glass has cooled down in molds, a machine cuts a glass tube into pieces of the right length. The cut tubes land on what's called a polishing wheel, passing through a gas flame for 7 seconds. This heats the glass enough to polish the surface. The polished tubes enter another machine that heats them until the glass is malleable. Then, one end is stretched to give it a flared shape. The next machine places 2 copper conductive wires into the flared end, then inserts a thin glass cylinder called an exhaust tube. Passing through a series of increasingly hot flames softens the tubes. A press comes into action to squeeze them and insert the wires into the glass. At the same time, the machine makes a small hole between the wires and the glass, which will be used later to remove the air. The machine then separates the conducting wires and bends them into hooks on the ends, which will hold the filament. A thin coil of wire made of tungsten, the only metal capable of producing continuous light. Any other metal would extinguish after a few minutes or hours at most. Tungsten emits a white light when heated to a temperature above 1,300 degrees. The issue with tungsten is that it can't be near oxygen to function. That's why the bulb is essential, to create a vacuum and isolate the tungsten filament. Next, a machine engraves the voltage, wattage, and company logo on the top of each bulb. Some bulbs are sprayed with an interior coating of synthetic silica. The coating machine charges the bulbs with high voltage and the right amount of heat. This electrical charge causes a fine layer of dust to adhere to the glass. A series of flames evaporate the moisture and remove impurities. This machine can produce over 50,000 bulbs in an hour. When the 2 production lines merge, a bulb is placed on each holder. The torches then solder the flared end to the neck of the bulb. Arms shape the neck to fit inside the aluminum base. The next machine evacuates all the air and replaces it with pressurized argon gas. This gas resists heat buildup and contributes to the filament's longevity. In most cases, the gas is a combination of argon and nitrogen. Eventually, the filament will gradually evaporate. Incandescent light bulbs have an average lifespan of 200 to 750 hours. As the tungsten evaporates, the movement of the gas inside the bulb spreads, condenses, and gives the bulb a dark grayish color. After bending the conducting wires and moving them aside, the torches melt and seal the exhaust tube, enclosing the argon gas. The bulb is now ready to be screwed into a light socket, but it needs a base. The base is made of aluminum. This machine inserts one of the bulb's wires through the center and solders it in place. It then spot welds the other wire to the side with the input wires touching the aluminum base for proper electrical contact. The bulbs undergo a series of repeated turn-ons using progressively higher voltages. This strengthens the filament and reduces the chance of breakage during transportation. The automated packaging system handles the fragile bulbs with care. The bulbs are placed in their packages and sent to consumers. While heating a filament until it shines is a satisfactory way to produce light, it's extremely inefficient. Only 5% to 10% of the electrical current is transformed into light. The rest is heat and is simply lost. About 95% of the electricity supplied to a typical light bulb is converted to heat, not light. In a world with dwindling resources, where energy conservation is increasingly vital, this inefficiency may eventually make the incandescent light bulb impractical. There are other light sources already in use that could supplant the incandescent bulb. Fluorescent tubes, for instance, already dominate the industrial market, and undoubtedly, they will find increasing use as a domestic light source as well. Fluorescent bulbs use at least 75% less energy than incandescent bulbs and can last 20 times longer. The recent development of compact fluorescent bulbs, which unlike the standard fluorescent tube can screw into a typical domestic lamp, may expand the domestic market for fluorescent lighting.
That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.